Okay, so in this video we're going to continue making connections between what we know about quadratics to all the other polynomials. And so the next step is really think about finding x-intercepts. We all know that when you're finding the x-intercept of any function, you set y equal to 0 and then solve for 0. And with parabolas we've done that a fair amount. So in this case you would set it equal to 0 and you'd factor it if you can. If you can't factor it, you'd put it in the quadratic formula. But this one is factorable. So we come up with x and x, and this would be 2 times 3 is 6, and 2x plus 3x is 5x. So we have a nice, this is that same quadratic equation written in factored form, and it's set equal to 0. Now the zero products rule says that if I multiply something times something and it equals 0, that means one of the somethings has to be 0. So therefore, either x plus 2 is equal to 0, or x plus 3 is equal to 0, which means that x is equal to negative 2, or x is equal to negative 3. And those are what we would call the zeros of the function, or the roots of the function, because they make the function equal to 0. But they also give us the x-intercepts of the function, because when the y value is equal to 0, that means we're sitting on the x-axis. So, and just from knowing that, we could, of course, graph this to some point or some degree or another. Maybe not perfectly, but we know that since it crosses at negative 2 and negative 3, we can look at this and tell that it's the leading coefficient would be positive, right? Because that's a positive 1, which means open up. And now I don't know exactly where the vertex is, but I could take a rough guess and say, oh, this thing kind of looks like this. Now I might be off on exactly where the vertex hit, and I might be a little bit off on, well, I know that I'm off on how wide or skinny it is because I didn't really pay attention to that. But that is the basic idea, because I know it has to go through these 2 points, and it has to be open up, or as we talked in the last video, the end behavior is positive infinity on the right and positive infinity on the left. So we know that this thing ends up heading off into space, not as opposed to going down. So we know the vertex has to be down below the x-axis, and the arrows are headed up. Okay? So again, the important connection here is the connection between the factors of the quadratic and the x-intercepts. So if you have factors, then you know the x-intercepts. And the x-intercepts, or the roots of the equation, are the number that makes the factor equal to 0. So you can see when I plug negative 3 into here, I get 0. When I plug negative 2 into there, I get 0. So this is a really important connection, the connection between factors of a polynomial, because this is a type of polynomial, factors of a polynomial, and their x-intercepts. So let's do one more example here. If we write this in factored form, this would be x minus 2 times x plus 2. So again, if we understand that connection between factors and zeros, which are also x-intercepts, we can just look at this and say, oh, the x-intercepts are x equals 2, which comes from that one, and x equals negative 2. Why? Because if I plug 2 in there, it makes this factor equal to 0. If I plug negative 2 into there, it makes this factor equal to 0. So that tells me right away that there's an x-intercept at negative 2, and 2 has a positive leading coefficient, so it must be open up. And we actually know that this thing crosses at negative 4 down here, because if we plug 0 in for x, that's a y-intercept. And so we can draw this parabola real nicely. That's pretty precise, actually, if I would have hit that point. Right? So the key here is the connection between factors of a polynomial and the roots of the equation, or which lead us to find the x-intercepts. So if we, again, try to apply that to further, let's say that we have an equation like this that's in factored form already. X plus 2, x minus 3, let's say x plus 5. So first of all, we want to identify this. This is a polynomial in factored form. What degree polynomial is this? Well, when I multiply it out, I know I'm going to have to multiply x by itself 3 times. So I know this is a third degree polynomial. And I know that I can see the factors. So remember the connection we made earlier is the factors of a polynomial make it really easy for us to find the x-intercepts, or the roots. So we can tell right away that the roots of this equation are x equals -2, x equals 3, and x equals -5. So that's awesome. Which means if those are roots, those are also x-intercepts, right? So if I was to go to and try to draw this thing, I know it crosses at -2, crosses at 1, 2, 3, and crosses at -5. 2, 3, 4, 5, 5. Now, all I can see now is 3 points, but then think about in behavior. So this is a third degree polynomial, which means it's shaped, in behavior-wise, it looks something like that, and meaning that on the right is positive infinity, on the left is negative infinity. So I know this has to end up headed up this way and on this end like that. So just from that, I can roughly sketch out this polynomial. It must do something like this. Now that's just a real quick sketch. It doesn't necessarily hit the right places down here. I'm just trying to rough it in. But I do know that this point is for sure, this point is for sure, this point is for sure, and the end behavior is correct. I know that I should be headed up towards infinity on this side and headed down towards negative infinity on that side. So again, the important connection here is between factors and roots, which lead me to x-intercepts. Okay, let's look at another example. Let's say that I have y equals -3x times x plus 2 times x minus 4 times 2x plus 1. Okay? So first of all, let's identify the polynomial. Looks like I have 1, 2, 3, 4 factors of x, because when I multiply all that stuff together, I'm going to have to multiply all those together at some point. So I know that this is a 4th degree polynomial. Which means, and the leading coefficient. So I'm going to multiply 2x by x by x by -3x, which means in the end, it's going to be a negative leading coefficient. So I'm dealing with a negative leading coefficient in a 4th degree polynomial, which tells me it's going to look something like this. AKA the end behavior is going to be the limit of y as x approaches infinity is negative infinity, and the limit of y as x approaches negative infinity is also negative infinity. So it's going down on the left, going down on the right. Okay? Then we also notice that there's 4 factors up there. So the roots of this polynomial would be 0 because of this one. Because if I plug 0 in for x, it makes this factor 0. And then we'd have -2 because of this one. Then we'd have 4 because of this one. And then in this one, we'd have -1/2 because of that guy right there. Because 2 times -1/2 would be -1. -1 plus 1 is 0. So then when we go to graph this thing, again, I'm just drawing a rough sketch. I won't be sure about how deep or high to make the bumps and valleys, but I do know it crosses at 0, 0, at -2, at 1, 2, 3, 4, and at -1/2. I also know that I've got to be headed down on either end of it. So that tells me that it's probably going to come up like this, or just a little, make it rounded, right? Make it, this is probably going to have more time to go up, so come back down and then end off like that. Okay? So again, I want to emphasize that these are rough sketches to just get a basic shape of the graph. I'm not worried about whether I hit this at the right place or this at the right place or that at the right place or any of these points. I'm not guaranteeing they're all in the right place. But I do know that the X-intercepts are all correct and the end behavior is correct. And that's what we're headed for right now, for just a quick sketch of the polynomial. All right. So this kind of ends the introduction to polynomials as far as making connections from what we know about y equals x squared for the quadratic family, and what a little bit we know about the cubic family, and then we're connecting that to all the polynomials in general. So you can see this is a fourth degree polynomial. It's not a part of the quadratic or cubic family, yet there's some similarities to how it behaves, and that's the point of this. So we can use that to get to know the polynomials better.